Okay. So basically, in this lesson, they're going to give you a word problem, and then you're going to have to come up with a equation. Yeah, and I said I'm not going to skip it because I need you guys to know, because a lot of the homework questions is going to have some decent.
So we're going to do it.
Yeah, we should be able to. Well, let's see this one first. Okay?
Okay.
So in this lesson, you're gonna create the equation of the line. Okay? It's not gonna be given to you. You're gonna make it up. So to model a word problem using a system of linear equations, you must declare your variables. Using a let statement. So when I say declare your variables, that means if you have, let's say, the two variables x and y, right? You want to tell me what x represents and what y represents. Okay? So when you read the question, it says, let's say, the equation is c equals 3x plus 5, where c is the cost of the total cost, and then x is the number of scale points. So in the question, they're telling you that c is your total cost, and x is the number of scale points, right? So in this case, you are going to say that because the question will not tell you that, and then you're going to make up the equation. So it's your job to declare your letters, what your letters mean, and then you're going to make the equation. Okay? And then you're going to write each of your, or create each of your equations. So we're going to learn two different types. We're going to have one with a single scenario under similar conditions. Okay, so let's read that question. So Jason weighs 6 kilograms, less than twice of Bill's weight. If the sum of their weight is 102 kilograms, how much does each person weigh? So what are my two things that I'm comparing? 6 kilograms. Less than. But what am I comparing? Their weight. Whose weight? Good. So this is what your let statement is going to be. So let J be Jason's weight, and let B be Bill's weight. Okay? So now you know what you're comparing. You're comparing this weight to that weight. Okay? You can call them whatever letters you like. Okay? So you're gonna say let J be or represents Jason's weight. And B So let's look at the first sentence again. The first sentence says, Jason's weight is 6 kilograms less than twice his Bill's weight. So how can I write that as an equation? So Jason's weight is 6 less than twice of Bill's. So when I say Jason's weight is, how can I start with that writing down? Remember that I have to, J equals, that's perfect.
Would be -6.
Okay,
Would it?
yeah, keep going. But it's 6 kilograms less than twice of Bill's
So it would be like a 2 times.
2B. Yeah, that's right. Because twice of Bill's weight, so that's 2 times Bill weight. So 2B, right? So it's going to be J equals 2B and then minus 6 because it's 6 less than that. Does it make sense?
Yeah.
Does it make sense, Danica? Because it's twice of Bill's weight.
Yeah.
It says twice of Bill's weight. So 2 times B is, so if Bill's weight was 10, 2 times 10, that's 20.
Okay.
Right?
That
So
makes
it's
sense.
twice of Bill's weight. And then it's 6 less than that. Right? So it's minus 6.
Okay. That makes sense.
Okay.
I wrote it down to make it clear. Yeah.
Now, let's keep reading. So that's the first sentence. If the sum of their weight is 102 kilograms. So how can you transfer that to an equation? The sum of their weight. What does sum mean? Subtraction, addition, multiplication, division. What's sum?
Sure. Multiplication.
So you're summing, so add, you're adding. Okay? So when the sum, so the sum of their weight is 102 kilograms. So that means when I add J plus B,
Yeah.
I get what? 102.
And yeah, I didn't hear that.
Because it's a sum. Sum means add. So for now, we're not gonna do anything, we're just gonna leave it, we're just taking the equations, we're not solving. Okay? We're gonna learn how to solve them either by, we already learned how to graph them, right? But also we're gonna learn how to solve by doing 2 other methods. Okay? So, in this case, we are comparing 2 different weights to each other, right? But in this case, the single scenario is that their weight, right? Okay, now the other one would be under different, not similar condition. Should be under different conditions. Because this is one condition, this is a longer condition. Yeah. And the second is when you have 2 scenarios. Under similar conditions. Okay? So when I'm talking about 2 scenarios under similar conditions is when you have, let's say you're comparing 2 companies, right? The prices of 2 companies. Let's say when you're comparing the Bell Canada to Rogers, okay? And then you're gonna see how much it costs you. Or when you're comparing a rental company to another rental company, right? So you're gonna see, you're looking at different scenarios, different companies, but they have the same conditions. You're gonna pay a down pay, you're gonna pay your initial fee, and then you're gonna add, depending on how many kilometers you drive, or how many minutes you talk, or something like that. Okay? So let's read the problem. Carl's Towing charges $80 plus 0.22 cents per kilometer.
Carl would be A.
Bev's Towing charges $70 plus $0.3 per kilometer. Write a linear system to represent this problem. Now, so I have two scenarios. What are my two scenarios? Well, what are my two scenarios? What are my two companies? Carl and Beth. So my scenarios are Carl and Beth, right? Now, I'm comparing for both of them, I'm comparing what? The price for towing, so that's the cost, versus what? So the cost versus how many kilometers, right? So cost and distance, this is what I'm comparing, right? So their total cost versus how many distance they're driving, okay? So my let statement is going to be, let C be the cost or the total cost, and we're gonna say D be the distance in kilometers. Does it make sense? Okay. So I'm gonna read Carl's towing charge. So Carl's towing charges is $80 plus 0.22 per kilometer. So how would you write that as an equation? So what would be your total cost? 80. Is it just 80? So the cost is going to be just $80? Just 80? Or are we gonna say and pay anything extra? Plus, like literally plus 0.22
D.
times D, right? So if you drive 10 kilometers, that's gonna be times 0.22. If you're gonna drive 300 kilometers, you're gonna multiply it by 0.22, and then you're gonna add it to your initial fee, which is $80. Does it make sense?
Yes, we can do the same thing for Beth.
So what would be best? So he charges $70, or she charges $70 plus 0.3 kilometers, $0.3 per kilometer. So how would that be?
C equals 70 plus 0.30 D.
Yeah, that's right. You got it. So anytime you're comparing two different things, don't worry about their names. Put their names on the side so you know what they belong to. Okay? Put the names of the companies on the side, but make your equations, because in this case we are comparing the cost to the kilometer. Right? These are my variables. And this is where a lot of students make the mistake, is they go and then they stick the Carl and the Bev in there, but that has nothing to do with that. Okay? You can only have two variables in your equation. Okay? So if you find out that you have 4 of them, there's something wrong. Go back and check. There's something wrong.
Don't we read that one, boys?
And you don't understand how that gets scared when you walk into a classroom.
Right? Yes, yes, and yes? Then no, we can go.
So now it's like
Right, so we're gonna wash up. Yep.
Okay. So let's look at this. Jill makes 2 types of quilts. The first costs $25 for fabric and $40 per hour for hand quilting. The second type costs $50 for fabric and $22 per hour for machine quilting. For what numbers, you don't have to solve, but for what number of hours are the costs the same?
D cost and H per hour.
That's right. So technically, a lot of times your question is gonna tell you what your variables are going to be, right? If you read this, what number of hours, so that means you're looking for hours, are the costs the same? So it's telling you, right, what your variables are going to be. So I'm gonna say let H be the time, but it's gonna be in hours, right?
Yeah.
So I have to include the unit. the time in hours, time can be in seconds, it can be in minutes, right? And C, the cost. Right, cost, we know, all of us know that cost is in dollars, right? Unless it's like thousands of dollars, right? Okay, now what would be my first equation? So the first type costs $25 for fabric and $40 per hour. 25, that's it? Okay, plus?
For TH.
Or TH, that's right. So that's the first quilt, and then for the second kind of quilts,
C equals to $50 or per year. Plus, that's what it is per year, 22 each.
very good.
So that's it, without running.
That's it, you don't have to solve. A band held a concert in its hometown. A total of 15,000 people attended. The tickets cost $8 per student and $12.50 per adult. The concert took a total of 162,500. How many adults came to the concert? So is this kind of like the first question that we did, or is it kind of the second question that we did?
Second.
It is the first one. It is the first one, right? Where you have one scenario which is talking about the concert, right? You don't have two different companies. You have a scenario talking about the concert, but you have two different conditions. Okay, let's read the second sentence. A total of 15,000 people attended. What does that mean? So they're asking for adults. Now I have two different types of tickets. I have the adult tickets and the children's tickets. So, but then when you count people, right, do you count just adults and kids? Or you can add everybody. How much is everybody? How many people attended? So that means the number of adults and the number of children equal to 15,000. So what would be my variables?
A for adult.
So the number of adults is going to be for A, yeah? So A is the number of adults. So let A be the number of adults. Okay. And what would be my second variable? So you're paying $8 per student and $12.50 per adult. As for students, you have to know how many students attended, all right? Because the total price is going to be depending on how many students attended, right? So we're going to be let A be the number of adults and let S be the number of students. So let's read the first sentence again. A total of 15,000 people attended. So how can I write an equation for that? Only adults attended? So I have adults and students attended to make 15,000. That's right. What will be the second equation? So the ticket costs $8 per student and $12.50 per adult. to make a total of 162,500. So let's say, okay, I'm gonna give you something else. You went to buy chocolate, okay? Twix cost $2 for Twix, and then Kit Kat cost $1, or let's make it the dollar. Okay, now you paid $10 in total. Okay, how can you make an equation for this? Let's say if you bought 5 Twix, how do you know how much it cost you for the Twix? If you bought 5, what do you do? Huh? So you bought 5 Twix.
Yeah.
What do you do? Count by 2s or do 2 times 5.
Yeah.
Right? Okay. So you did the price times the number, right? So price times the number, and that gave you the total money that you spent, right? Let's say you bought 6 Kit Kats. What do you do to find how much did you pay for the Kit Kats? Multiply it. So it's going to be 1.5 times 6, right? And that's going to be your total money that you paid for. Okay, eyes on the board. Now, if you want to know how much in total you paid, you add the both of them, right? You add the number of, the price times the number plus the price times the number, right? Okay, so let's say we don't know how many Twix you bought, right? You bought X number of Twix. Okay? And you bought Y numbers of Kit Kat. Okay? Then you're gonna have to add the total. But look what's happening. You're multiplying the price by the number of Twix. The price by the number of Kit Kats to get the total. Okay? So in our case right here, do I know how many adults attended? No. But do I know how much each adult costs? How much? $12.50. So if I do $12.50 times 8, right? And then plus how much each student paid? 8 times how many students attended, I can know how much they paid altogether. Right? So it's like I do this. So 2x plus 150y. That would be my total price of, let's say, $20 I paid altogether, right? At the grocery store. Okay. So show me how would you write that for the what we have. So how much each adult paid? $12.50. So $12.50 times A, right? Because this is how many adults attended. Okay. Plus 8 times X, equals to because altogether they paid this much. So if you look here, let's say 10 adults attended, right? So 10 times $12.50, that's going to be $125, right? And then let's say let's say 100 student attendance, so that's $800. If I add $800 plus 125, it's gonna give me $1. So this is why when you're making your equation, it has to be dollars to make dollars and numbers to make numbers. Because A and S is the number of adults and A number of students. Make sense? We start a little bit harder than the previous question, right? Yeah. Okay, so what I want you to do right now